Okay, we have to cover section 4.2, and it's going to be about solving quadratic equations. I hope you're picking up on the word equations, because we had been talking about functions, right, where we had f of x was equal to ax squared plus bx plus c. But now we're just going to set the function equal to 0, so we have a standard form, ax squared plus bx plus c is equal to 0, and that's our new standard form, okay, for an equation, quadratic. Standard quadratic equation, okay. Alright, so what you have to realize is we keep going round and round on being real picky about this form and everything, and we have lots of different words that mean the same thing. So when I'm asking you to solve this equation, I'm going to find a solution for this equation. I could also say I'm going to find the roots of this equation. That's just another word for the solution. I think we've talked about this once before. I could also have called these the zeros of the function, the quadratic function, and say here's f of x again, find the zero of the function. And also there's one other way you can think about it. You could say these are the x-intercepts. That's x-intercepts of the graph of the function. Okay, so all these words all mean the same thing, so we're going to use them interchangeably. So if I asked you to solve x squared minus x minus 6 is equal to 0, okay? Now, I'm going to solve this first by graphing, okay? So what I'm going to do is however your favorite way of graphing is. So I could, we spent all day yesterday learning how to graph these quadratics. I could ask you to do that. You can graph by using table of values, whatever your favorite way, but let's say I even let you use your calculator to graph it. So you're going to pull up your calculator, you're going to look at this, and you're going to say, okay, here's what my calculator is showing me. It's showing me a graph that looks like this. Okay, here was my y-axis, my x-axis, and on this graph I can see, maybe I trace it, or however I do it, I can see -2, 0 is a point on my graph, and 3, 0 is a point on my graph. Those are the solutions, those are the x-intercepts, because that's where the graph crosses the x-axis. Those are solutions for this equation that we talked about here. They are roots of that equation, and they are zeros of the function. So my answer would be x equals, because we give solutions as x equals, -2 and x equal 3 is my solutions. Okay, those are my two solutions for this one quadratic equation. Alright, let's try another one. Alright, let's say I want to solve this one, x squared plus 6x plus 8, and I'm not going to graph it on my calculator. I'm going to use a table. Okay, so in this case I kind of would like to have an idea of about where to set my table. So I need to pick some x values for in the table. Where am I going to get that started? So I'm going to start by the vertex. And that I know will give me a place to start with my x values. So x is equal to -6 over 2 times 1. So x is equal to a -3 is my vertex. So I'm going to make a table of values. I'll start at x equal 3, negative, and just keep going. Okay, I only need to check one side because I'll get the other side by symmetry. So I can go ahead and put these all in and find all these values by plug and chug, or we can use the table feature of our calculator, which is nice to do as well. So let me do that real quick. And let's see. Do I have that right one in here? Yes. So in the table. Alright, so I get -1, 0, haha, and 5 I get 3, and I'm not even going to bother going any further, sorry. So I don't need to go any further because I found a solution right here. So that's going to be a solution because y is 0. Okay, and that's, this is giving me, Did I really do that? I have to solve that equation. Oh, that was a deadly sin right there. You don't solve expressions. I had written an expression up here. I really needed it to be an equation so I could solve it, so I had to have it set equal to 0. My apologies. But here I have found now the solution because the y value is 0. And I can, graphing this if you want to think about it, but you'll get good and can do it without graphing. -3, -1, -4, 0. If you want to go ... there's my axis of symmetry down through this vertex. So my other solution will be symmetrical across that axis of symmetry at -2, 0. Alright, so you can almost see that in the chart as well if you get good at it. So my solutions are x equals -4 and x equal -2. So those are my two solutions to that equation. Okay, one of the things that's fun to talk about is how many solutions can you find. And, so far we've been finding 2 solutions, and that's pretty typical for quadratic. You don't want to find more than 2, that's for sure. So you can have 2, or you might have 1, or you might have 0. So let's talk about those special cases. We've already been talking about the 2 case, where we had a graph, and maybe it looks like this. And you look at that and you say, wow, there are 2 solutions, one here and one here, because remember the solutions will be the same as your x-intercepts. But another thing might happen. Okay, so wait a minute, let me go back. This is 2 solutions. What else might happen to a quadratic graph? Well, you might have a graph that comes down, just kisses, I gotta get it right, just kisses that x-axis, and you have a single point. The vertex lies on that x-axis. So in that case, you have just this one point here for a solution and no other solution. So just that one solution. The other thing that might happen is you have a graph. When you graph it and you find out, okay, it comes up, oops, and then it turns around and comes back down. And you sit there and say, well, here's my vertex, here's the highest, the maximum value, and nowhere does this graph cross the x-axis. There are no x-intercepts. So guess what? There's no solutions. Okay? You will never find an x value for which the function for this parabola would equal 0. Okay, so 2, 1, or 0 are your choices for how many solutions. Okay, we want to try something a little different. We want to try a word problem, okay, where we're going to do 2 numbers have a sum of 15, and those same 2 numbers have a product of 63. How would you go about solving this? So let me show you how I would do this. I would say let x equal the first number, y is equal to the second number, and then I would make each of these into a equation, because right now they're just a word sentence. So I would say the sum of these 2 numbers, so x plus y, that's the sum of the 2 numbers, is 15. And then I would say the product of those 2 numbers, so that's a times, is equal to 63. And now I just have to solve this system. So I'm going to do what I do when I normally do systems, and I'll use substitution. I'm going to say y is equal to 15 minus x. So this equation becomes x times 15 minus x is equal to 63. So 15x minus x squared is equal to 63. Let's put that all in one kind of standard form. So x squared minus 15x plus 63 is equal to 0. And now I have it in a standard form. And then honestly, what I would do with this equation, I would throw it in my calculator. I would take a look at it, and here's what it looks like in my calculator. X and y, it looks like this. So what's the solution? No solution. So there are no 2 numbers whose sum is 15 and their product is 63. Alright, let's try something a little different. I have a problem here that's going to illustrate what happens when, the numbers don't come out real nice and we're just going to have to estimate things. So if I had this equation and I wanted to try and solve it by using a table or something, I would say, well, let me see what the vertex is so I could get this started. X of the vertex is equal to 6 over 2 times 1, so x is equal to 3. So let me start a table of values, okay, with 3 as one of my choices. Let me start here, and I'll just go, maybe I'll try 2 and 1 and 0. Those are some good x values, and really I'm doing f of x over here. So you plug and chug with all of those, and what do you get? You look at this and you say 4. When x is 1, you get a negative 1, and then you get a negative 4, and then you get a negative 5. So that's my vertex, right? But that doesn't help me solve this equation. So what do? Okay? Well, actually, the solution is lurking in here. It's just harder to find. So let's graph it. Okay, so I have vertex 3, negative 5. I have 2, negative 4. I have 1, negative 1. I have 0, 4, like that. Okay, so I have this sort of graph like this. So I can see the x-intercept lies between this value and this value that I found. So that was where? That was this one and this one. Well, that's exactly where it changes from positive to negative. If you think about it, the only way for the y values to go from being positive y values, like y equals 4, and then all of a sudden it magically changes into a negative y value, somewhere between those 2 points, y has to equal 0. Okay, so y has to equal 0 somewhere where it changes from a positive to a negative. So I can say y, oops, let me say this, x, the solution is x lies between 0 and negative 1. Okay, so that's a, whoops, I'm sorry, 0 and plus 1. So that's all I can say right now, is it lies between 0 and 1. But of course there is a second solution because you know it's going to go back up this way, right? So let's see if we can figure out what those two values were. 1, 2, 1, 2. That gives me this one at, oops, now I've lost it. That wasn't there. So that's 1, 2, 3, 4, 5. That is 5 comma negative 1. And then this point up here, let's see, this is my axis of symmetry. Got to go carefully here. This was a distance of 3, so I have to go 3 more over here. So this is 6 comma 4. Okay. So now I know x lies between 0 and 1, and the second x lies between 5 and 6. Okay, so that's kind of estimating. And maybe I'll say, it's about 0.5 and about 5.5. So that's solving by estimating. Okay, so the next thing I wanted you to do was some of the check your understandings in your book. You had some questions to do, and I think I'd ask you to do numbers 1 through 5. So in the back of section 4.2, you'll find those questions 1 through 5. So go ahead and do those, and I'm just going to put the answers up here for you to check your work.